Okay, this is video 5C of the of my videos on particle physics, and this one's covering pair production. So pair production is almost the opposite of annihilation. So you've hopefully just watched some videos, made some notes on annihilation. Annihilation is where a particle and its corresponding antiparticle collide, and all of their rest mass and any kinetic energy is converted into two photons of equal energy. Pair production isn't quite the opposite. Pair production does involve the production of a particle and its antiparticle, such as an electron-positron pair. But that doesn't occur from a pair of photons. Instead, it occurs from a single photon. Okay, and the condition is that the energy of the photon must be greater than or equal to the rest energy of the two particles. Right, so if we get the equal to condition, the two particles will be created but stationary, and so they're going to re-annihilate. If we get the greater than condition, the two particles move off in opposite directions. And note what's happening here. We are creating mass from something that has no mass. So in chemistry, in GCSE physics, in general, we assume the conservation of mass. But here we have not got the conservation of mass. Remember, the particle and its antiparticle have positive mass. There is no such thing as negative mass. And therefore, mass is not conserved in this situation. What is conserved, we might call mass energy. So some energy is converted to mass, but if we take the total energy of the photon, hf or hc over lambda, and we take the total energy of our particles, both their rest energy and their kinetic energy, then those two things will be equal. But pair production can't happen, and this is a large part of many of the questions, is the photon energetic enough? Does it have enough energy to produce electron-positron? Does it have enough energy to produce a proton-antiproton? And clearly, the electron-positrons are lighter, they have less rest energy, and therefore we need a lower energy photon to produce them. So what are we saying? The question might be, can a photon of energy, what might we be talking? I'm going to pause the video here and work out a sensible number. So, sorry about the pause there. Can a photon of energy 20 MeV produce an electron-positron pair and neutron-antineutron pair? So we look to the formula sheet, and we'll find on the formula sheet that the rest energy of an electron is half an MeV. So if we're going to produce an electron and positron, we're going to need just over 1 MeV. Our 20 MeV photon is more than adequate. But to produce a neutron-antineutron pair, we're going to need nearly 1900 MeV. So our 20 MeV is just not going to cut the mustard. So how might we show the examiner that? We might say total rest energy of our electron-positron pair is equal to 2 times 0.511 MeV, which equals 1.022 MeV. And then we might say, since 1.022 is less than 20, the pair can be produced. And then we might have a part 2. How much Ke does the pair have? And so what have we got? Well, we've got energy of the photon is equal to the rest energy. Well, that looks like a K, doesn't it? The rest energy plus the kinetic energy. So how much kinetic energy have we got available? Well, that's the energy of the photon minus the rest energy, which is equal to 20 MeV minus 1.022 MeV. Now you've got to remember that that energy is split between the two particles. So what does that equal? That equals 18.999. Oh dear, how embarrassing. 978, I think. I might have got that wrong. I've just done it in my head, but you'll forgive me, I'm sure. So, but that's the total kinetic energy of both particles. But the kinetic energy per particle will equal 18 point, and remember we're perfectly at liberty to do that, divided by 2. And so let's do it on a calculator now. 20 minus 1.022, got it right, thankfully, divided by 2 equals 9.5 or 9.489 MeV. And it's very likely there'll be a mark for converting that to joules, but I'm not going to bore you with that. So pair production, one photon goes to two particles. And I'll remind you of the difference to annihilation: two particles, two photons. So they are not the exact opposite of each other. One photon, two particles. The critical condition is that the energy of the photon must be greater than or equal to the rest energy of the two particles. Any spare just gets divided up as kinetic energy. So then quite often the questions involve telling us the energy, probably in joules to make life harder, and then us working through. So that's a really short video on pair production. The assignment involves reading the textbook just to check you're happy, and we'll have some time to consolidate next week. That's the reason we do these videos. But do watch it a couple of times. Hopefully I've not made any speaking errors when I've been talking without a PowerPoint, but I just felt trying to run through these calculations was better done by hand today. I would appreciate any feedback either by email, or I will put out a Microsoft form at some stage. This is clearly a very different format to the PowerPoint. Both have advantages and disadvantages. I'd be very pleased to hear your thoughts on which you preferred and why. Many thanks.